Our learning objective was explain how cells control the quality of RNAs exported from the nucleus. So first, of the many pre-mRNAs that are synthesized in the cell, only sequences contained within mature mRNAs are useful. So the remaining RNA fragments, which includes excised introns, broken RNAs, and abnormally spliced transcripts, are not allowed to leave the nucleus, and they're useless. Not only are they useless, but they could potentially be dangerous to the cell. That's why there's a highly specific process on how RNAs are transported from the nucleus.
And this process is highly selective, and it's mediated by the nuclear pore complex over here. And this nuclear pore complex basically acts as a gateway between the nucleus and the cytosol, and it determines what macromolecules can leave or enter the nucleus. And for an mRNA to be export ready, it needs to have a certain set of proteins that mark it for maturity. And the first one is a cap binding protein over here, and it attaches itself to the 5N cap over here. And the second one is a poly A binding protein on the poly A tail. And the third one is an exon junction complex, which basically is just marking the mRNA that it's been correctly spliced. And this set of proteins is signaling the nucleus that it's ready to leave the nucleus. And once that happens, a nuclear transfer receptor comes and guides it out into the cytosol, where the mRNA can shed some proteins, bind to new ones, and with the poly A binding protein, undergo protein synthesis.
So the failure waste RNAs that are not used in this process stay in the nucleus and they will be recycled. They do not go anywhere because, like I said before, they can be potentially dangerous. And like Jenna mentioned, after the quality check in the cytosol, the mRNA can shed some proteins and bind to new ones for protein synthesis.